Okay, everybody, excuse the mess on my bench here. I'm reordering stuff here. I got some supplies I need to put away and whatnot, so I'm a little bit of transition mode here. But what I want to talk to you folks about is linear regulated power supplies. So whether they're lab power supplies like that you commonly see, this one here is 3 amps, 0 to 36 volts, I think. And then, of course, the infamous Astron power supplies, running with, I think, 723, 3055 series pass regulator. Bad juju when it comes to RF, so that's what we're going to talk about. So I recently blew up my new Kenwood here. It wasn't even powered on. I was talking on HF, didn't even have the amplifier on. It's probably 80 watts, and smoke started bellowing out of here. Just black smoke filled the room up. Oh my God, it stunk like a tail end capacitor. And we're going to talk about what happened. So basically what happened is there's some RF coming down, not a lot. I checked it on the spectrum analyzer. It's microwatts, literally. But there's some RF on the outside of this shield, this LMR 400, which goes up to my roof, the peak of the roof on this side of the house. And it's a dual band, 2 meter, 70 centimeter antenna. It's the Diamond X50. It's a gain antenna, about 5 feet tall. It is in the general vicinity of the HF wire antennas out back. They're close, but I wouldn't consider them dangerously close. And I did kind of measure that with the spectrum analyzer. Didn't see anything that I was worried about. But in any event, there's enough RF on this shield, which isn't much, to set that power supply off into Never Never Land whenever it receives that RF. So it's only when the ground connection of the power supply is connected to either the outside shield or the coax, which by design on most of these radios is also the negative side of the power supply, excuse me. And we're going to see that here today. So basically, I'm on 40 meters here. I did turn the power all the way up and it's tuned up just to show you the maximum effect of what we're going to see here. So I have the meter across that power supply there. That's originally what I had on the Kenwood when I blew it up. So we're going to just hit our foot pedal here and key up. I'm barefoot today. It's pretty hot today, or warm anyhow. Tuned up, and then we're going to watch this power supply, and you're going to hear the relays clicking. The relays click when it goes to different scales, 0 to 12, 12 to 24, 24 to 36. It's kicking in different relays, probably taps on the secondary of the power transformers, my guess. And here we go. KK7 Zulu Romeo. Oh boy, listen to this thing clicking. Hello audio. Hello audio. Oh boy, I see 15 volts. Yeah, and that's not a good thing. So it's not a good thing at all. So this is connected to the meter and not the radio. But prior to that, this was actually connected to the radio, and it turns out that there's a surge suppressor. It's basically MOV. It seems to be a Kenwood proprietary part, a little green thing. It disintegrated and blew up. I threw it away. Little MOV. It's across the power supply, and it's meant to fire at 17 volts. So when it gets 17 volts, it shunts. It wasn't able to blow the fuse. The fuse is pretty big in here, but it consumed itself, shorted, and burned up, singed some nearby wires. But I salvaged it, cleaned it up. Ordered a new one from Kenwood. The doggone thing is $15 with shipping and tax and whatnot. It's 20 some bucks. It's on its way in. But watch this. Hello audio. And the reason why it's on that supply is because originally I had it on my 30 or 25 amp, I think it is, maybe 30 amp Astron supply. And I had this nice rubber test lead wire. You get all kinds of test leads. This was actually looped up over the front, and that's actually to supply power to my SG235 tuner that's out back. And this is from a previous project, and that's kind of why I had this plugged into that, and that Cat 5 goes out to the tuner. And so when I bought the new Kenwood UHF VHF radio, I had the power supply just connected over to the leads here, click lead on. And when I did that, and I tuned up on certain bands, mainly 160, the amplifier started going all crazy. And I troubleshot that. I thinking, oh no, something's wrong with the amplifier. Well, it turns out that the power supply voltage was varying up and down on my Kenwood 890 here, and causing it sometimes to reset and power off. But ultimately what it was doing is varying the voltage and varying the exciter drive for the linear, which caused the needles to go crazy. And once I deduced that, I think, oh crap, there's just enough stray RF in here that it's causing issues with that. I tried to shut it out, bypass it to no avail. I says, well, heck, I wanted to talk on my new radio, VHF 2-meter rig, so I just connected it up to that. And then I noticed this whole business, hello, audio, right? And I was kind of aware of that, and so when I was on HF, I made sure just to shut the radio off. Well, it turns out shutting the radio off doesn't take that little surge suppressor out of the line, and that's what blew that up. So I went and did some research and decided to buy a nice switching power supply. My thinking was that if it's a switcher, there's no linear stuff, because those linear regulators, the 723, they're really high gain. So any RF that's in there that happens to get rectified is really going to screw up the op-amp circuits inside that regulator and cause that kind of havoc that we're seeing. So I found this one. It was relatively cheap. I don't remember the price. It's called a Tech Power. Really, really smart design. Got a little cigarette lighter thing if you have accessories, but it's limited to 10 amps for that. But the main terminals in the back, B and C. Relatively cheap. But anyway, I was looking at this, and interestingly, if you read this, what it actually says, it's a high-performance switching power supply. It is exceptionally immune to radio interference at close range. It's like small footpad. How about that? So it specifically talks about RF and it's immune. And I'm thinking, well, I made the right choice to get a switcher, a cheap one at that. I didn't need adjustable voltage. This one apparently is set. Made in China, obviously, I'm assuming. But as Chinese products go, this is one of the better ones where actually all the English is actually spelled correct. And the grammar is actually correct. I didn't see anything that looked really weird. So yeah, I was kind of impressed. So the kids coming out of college doing Chinese with American translation have gotten much better. So that's a good thing. On the website, it wasn't clear. They did say 23 amps max. Usually when it's max, that means there's a continuous rating, but I couldn't find it anywhere listed in the product advertisements online. But in this little brochure here, it does say 23 amps max and continuous 23 amps. Well, I think we looked at specs at this. This is a 50-watt rig for VHF, 25 watts on UHF for 70 centimeters. It only draws, well, actually on the full 50 watts, I think they said 13 amps thereabouts. So plenty of headspace there for that. This rig here, it's a 100-watt radio. Typically 100-watt radios, depending on the efficiency, 60% or so. Rough rule of thumb, I usually say is about 20 watts or 20 amps for 100-watt radio, HF 20 amps. But I remember measuring this, and it's not quite 20 amps when you key down. Well, we can actually see it here. I'm on CW, and I switched the meter to read. Let's see, yeah, ID, Eye of the Dream. So for the MOSFETs, and I think so. There's our 20 amp scale. So let's just key up. Not quite 20 amps. So hello. I don't know why it's moving, but there it is. So not quite 20 amps. We can turn the amp off. We don't really need that. The antenna's resonant. So anyway, so it's not quite 20 amps. This thing's rated for 23 amps continuous. Technically, I could run one of these on here. I thought, well, let me try this first. This is pretty cheap. I wouldn't want this thing to go crazy and blow up a $2,500 radio. Rather blow up a $350, $400 radio or whatever this one was. So I do have a Linko power supply switcher coming for this one. It's a little bigger than this. It has meters and stuff and adjustments, although I don't really need the adjustments. I don't need meters for that matter. I'm thinking maybe I should have just bought another one of these. I'm feeling pretty trustworthy on this one. So technically I could probably run both of these rigs off of here, because I'm very rarely am I going to transmit on HF while I'm transmitting on full power on VHF. So probably either or. So I could have easily done that. I might even try that today. This thing came with some really smart mounting brackets. They're in the box outside there in the kitchen where I unpacked and staged this. My crappy workbench here from years gone by. I could easily mount it right up underneath here. That might be pretty smart. That'll give me 12 volts for this rig if it stays in the shack. I might put this out in the truck and get another rig, or I could mount the rig here. I don't know. Workbench is all pretty hick. It's less than ideal. It's not nice and neat like some guys' shack are. But someday I'll tear it all down and make cabinets and everything like that. Probably when I move. In my mind's eye, this is kind of a temporary setup. So yeah, note to self: stay away from linear regulated power supplies, when you have any kind of RF, especially if you're running multiple antennas, be mindful of the feedback. As you see, I got a lot of lines coming in from outside. I got a lot of antennas out there. So you do have to be mindful. The ground wire I took off, I need to put that back up on the amplifier. I was trying to isolate all the grounds and put them all back together, trying to figure out that RF problem, and talking to a friend of mine, John K6IR. He's a smart cooking fella. He basically said, yeah, that RF's coming up on that negative lead. I could bypass it there. He said I should probably ground the negative there to the case and put the .01s up in there. But, I said, you'll be fighting that all the time. And all I need to do is have that thing break out into some sort of oscillation, run this thing over 13.8, blow that radio up again, or worse yet, blow up a 3500 radio. That would piss me off. So switchers are the way to go. I don't see any kind of RF getting in there enough to screw up that switcher. I think if you got the switching carrier PWM frequency all messed up, the thing will just go out altogether and just quit working, period. The oscillator will probably die and no power output is my guess. That's a lab compliance test that others can probably do. But anyway, there you have it. So stay away in the Astron. I'm going to sell that sucker. It's pretty new, 6 months, 10 months. I don't need any linear regulators for expensive radios. So we'll see you guys later.